Good morning, class. We are looking at section 8.1, the law of sine. We are going to look at how to solve triangles involving SAA, that means side angle angle, ASA, angle side angle, SSA, side angle, and look at applications, applied properties. So to refresh your memory, we have some fundamental identities, starting with the unit circle, periodic function, fundamental identities, a right triangle where a plus b is 90 degrees, a squared plus b squared equals c squared, even and odd function. We have sum, difference, double, half angles. We have many formulas here, reminding everyone what we've done. Again, going back to the right angle. Adding definitions, we have seen sine is the opposite over hypotenuse, cosine is the adjacent over the hypotenuse, so on and so forth. If we have a horizontal line, the angle of elevation, when basically we look up, angle of depression when we look down, the concept of a bearing or a direction, you either use just the north side and a clockwise, you look at the angle, or you look at the north, south, and the acute angle between them and the point of interest. In this case, for example, P1 is 30 degrees angle from north, so we say north 30 degrees east, and so on. Now we're going to look at the case where the triangles are oblique. In other words, the angles, none of them is a right angle, which means a 90-degree angle. So maybe all of them are acute. In this case, means less than 90 degrees. We have two acute angles and one obtuse, means larger than 90-degree angles. You can only have one of them to be larger than 90-degree angle. Only one. That is the only way to have it. And sine law, or the law of sines, sine A over A, sine B over B, sine C over C, they are identical. Where lower cases A, B, C represent the sides, uppercase A, B, C represent the angles in this case, or the vertices of the triangle. Needless to say, A plus B plus C must always be 180 degrees, and we take it from there. Cases of solving oblique triangle. Here's the summary of that, and we will look at examples. In general, in case one, we have ASA. A stands for the angle, S stands for the side. So the side is in between. Side angle. In both cases, we are dealing with two angles and one side. In this case, side is between the two angles. It's not in this case. Side angles, we have only one angle. But this angle is different than this one. This is called the included side angle side. So it's included angle. It's between the two sides. And we have all sides given. All sides given. and we want to find the missing ones. In all of these cases, the blue indicates what we have and the red indicates what's missing. We are looking to find those. In the first case, when we basically have two angles and one side, ASA angle, side angle, SAA side angle, one side and two angles results in one unique solution and one unique triangle. In case 2, SSA stands for side angle. You have two sides and angle. Opposite one of them. It's opposite one of them. And that's really the key. Could result in several different situations and solutions to occur. Consequently, SSA is referred to as an ambiguous case. We may end up with one answer. If A is acute and A equals H, if A is acute and A is larger than B larger than H, if A is obtuse and A is larger than B, we may end up with no triangle when A is less than H, and if A is obtuse and A is less than or equal to B, there is no triangle. In this case, we end up with two triangles where H is less than A less than B. We end up with two triangles. All of them will be looked at as we check some examples. This is the synopsis of different types. We also have two more types. Case 3, SAS, side, angle, side. There are two sides, and then the included angle, meaning the angle in between. So we have two sides and the angle is definitely in between. Then we have one unique solution. And the last case is when we have SSS, all sides are given. When we have three sides, then the situation results in one unique solution and one unique triangle, as long as one side is smaller than the sum of the other two sides. If you look at any side, it must be smaller than the sum of the other two when the numbers are given. Otherwise, there is no answer. And this last one requires cosine law. We can't solve it without the cosine law. So first, let's look at the proof of the sine law, also known as the law of sines. So in this triangle, we drop a perpendicular and we are looking at this angle, B, and we notice sine B is the opposite, which is H, over the hypotenuse, which is C. Remember, this is 90 degrees. This is the altitude H. We drop a perpendicular. This makes a 90-degree angle on each side. So H is the product of these two. If you do the cross product, now in this triangle, the right side and this angle, sine of this angle is the opposite H over the hypotenuse, which this time is B. And again, we do the cross product. H becomes B sine C because both of them are equal to H. Then C sine B is equal to B sine C. We're going to divide both sides by C as well as B to get rid of them. So let's divide both sides by BC. So what happens in this case, the C crosses out. So in this case, C goes away. In this case, B goes away, and we have this. We're going to repeat the process, but this time we are going to look at a different point, a different angle, a different vertex B, and we drop a perpendicular. So this makes a 90 degrees here as well as 90 degrees here. So both sides. So let's look at this angle. So sine of this angle is the opposite, which is H, over the hypotenuse, which is C. Bear in mind, this H is not the same as this H, and that's not what we are saying. Just like this one there, we look at this example now. And sine of this angle is the opposite H over the hypotenuse A. In both cases, we do the cross product. In this case, H is C times sine A. And in this case, H is A times sine C. And again, this H is not the same as this H, but in these two cases, they are identical. Because they are identical, C sine A and A sine C are the same. We are going to divide both sides by A as well as C, lowercase. So we're going to divide by AC. In this case, C drops. In this case, A drops. We get this one. And if you put these two together, you have the sine law or the law of sines. By the way, in some texts, they may just flip this over. Instead of saying sine A over A is equal to sine B over B, they might say A over sine A is B over sine B. It's the same thing, makes no difference. And ultimately, we have all of it. So sine A over A equals sine B over B equals sine C over C, or the reciprocal of each case. That's called the sine law or the law of sines. Now, even if they don't ask for the sine law, you may have to use it. So in this example, we are given A equals 40 degrees, B equals 60 degrees, lowercase a equals 4. Obviously, as you can see, if this is capital A, this is lowercase a. So let me just write it in case, not that you have to. So this is based on what's given. And so the very first thing, we have two angles. We subtract it from 180, we get the third one. So 180 minus the sum of these two. As you can see, the sum of these two is 100. Subtract from 180, and C is 80 degrees. C is 80 degrees now. Since this side is given, we use the sine law for this side since A, lowercase a, is given. So sine of 40 over 4 is sine of 60, the first one that was given. 60 over B is equal to sine of 80 over C. So this one and this one, we can separate them in this. manner. Sine of 40 over 4 is sine of 60 over B is sine of 80 over C. And now cross product. By now, I think everybody knows how to do that. So B is the cross product of 4 sine 60 divided by sine 40. I'm going to write this in case, but I believe we know that. So we have B sine 40 degrees equals 4 sine 60 degrees. And when we divide both sides by sine 40, that's what we get. At this point, you plug it into a calculator. Granted, sine 60 is square root of 3 over 2, but sine 40 is not a common arc. You plug it into a calculator, gives you the answer, and normally you use a couple of decimals, but you just follow what they ask you. In many cases, in some text, they just go with one more decimal. Since this is a whole number, they just use one more and they write it as 5.4. But you follow the instruction that is given to you. We do the cross product here, and lowercase c becomes 4 times sine 80 divided by sine 40. By the way, so this is 5.39. So from here, the cross product results in this. Again, you have to use a calculator because 80 degrees, 40 degrees, both of them are not common arcs. And roughly with a couple of decimals, we end up with 6.13. So C is given, replace it, and we got all sides, all angles. So when they ask to solve the triangle, that means find a capital A, B, C, and lowercase a, B, C, all angles, all sides. All right, in this situation, A is 35 degrees, B is 15 degrees, lowercase c is 5. So this is A. If we were to write this, this would be capital A, capital B, lowercase c. Obviously, we have two angles. We add them up, 50 degrees, and we subtract it from 180. We get the last one, 130 degrees. That is the fastest way to get one of them. So add up the angles and subtract it from 180. Now we can write the sine law. So we have 35 degrees and we have lowercase a missing. We have 130 degrees and lowercase c given. So we have to use this. So this is sine c over c. And now if I use sine a over a, I can find the missing a. So sine a over a, we know that capital A is 35 degrees. We know that lowercase a is missing. And we found the uppercase c to be 130 degrees and lowercase c was given as 5. And as you can see, a would be the product of these two divided by that. Again, I'm going to remind you here, I want to make sure that we're comfortable with that. So cross product means a times sine of 130 degrees is equal to 5 sine of 35 degrees. and we divide by sine of 130, that gives us A. Again, you plug everything into a calculator. Sine of 35 divided by sine of 130 and then times 5, and that gives you the value of A, which is 3.74 roughly. We use the sine law to find the missing B, so we need sine B over B. And it doesn't matter which one we use, but it is better to stick with what was given, because maybe in the process of calculation we made a mistake. So we better stick with this one. So capital sine C over C, we keep it, and sine B over B. So this is 3.74. Use this formula. So capital B is 15 degrees, lowercase b is missing, sine of 130 degrees over 5. So I want to use at least one thing that was given. So B is the product of these two divided by this one. So B is 5 times sine of 15 degrees divided by sine of 130 degrees. So product of these two divided by this gives you B because of the cross product here, okay? And so using a calculator, we get 1.69. So we're gonna replace the missing B with that. And we got all the angles, all the sides, and we are done. It was ASA, angle, side, angle. So angle, side, angle. So in this case, let's look at SSA, which is called the ambiguous case, where we have two sides and one angle, but the angle is opposite one of it. So in this case, we have A and B, and we have this angle which is opposite A. As you look at this case, obviously sine A is the opposite, which is H over B. So it makes H the product of these two, B times sine A. If A happened to be smaller than H, this is not going to work out. We don't have any triangle. If A is between the value of H, which is B sine A, and B, it can create two triangles. Because this is H, it can create two, one with all acute angles and one with the obtuse angle. Again, remember H is B sine A. So if A, which is the opposite of the angle that is given, is larger than or equal to B, we have one triangle. If A is equal to H, which is B sine A, we have one unique triangle which has a right angle. So we have one right triangle. Now, do we have to memorize this? No, we can go through the process and we can easily see whether they're going to work out or not. So let's look at a couple of examples. Let's start with this case. We want to solve the triangle where A is 3, B is 2, A is 40 degrees. So obviously we can use the sine law, and only one angle is given. So that angle and the opposite side must be given. We know the sine law. So of course, we can write them out. This is capital A, this is capital C. But even if we don't write them, we should be able to tell that sine of 40 over 3 equals sine of B over 2, things like that. And we can come up with the answer. But if we were to write this, we would recognize this is lowercase a, so this must be capital A. And this must be, it says it itself, capital C. All right, so according to this, I can say sine of A, which is 40 degrees, sine of 40 degrees, over A, which is 3, sine of B over 2, because sine of B is missing. So we can do the cross product. We've done it many times by now. Let me just show the cross product. And let's do it also this time, just to make sure everybody understands. So this means 3 sine B is 2 times sine of 40 degrees. In this case, you divide by 3 and you get sine of B. So 2 times sine 40 degrees using a calculator, whatever the number is, divided by 3 and you get 0.43 roughly. So sine is 0.43. How do we get to the value of B? Sine inverse of this is what we are looking for. We call it B sub 1, meaning we have two B's, and I'll explain it in a moment why, but for now, B or B sub 1 doesn't matter. The answer is 25.4 degrees. Why are we writing B sub 1? You know that sine is positive in the first as well as the second quadrant. So this gives you a unique answer when you use a calculator because of the inverse function. But you have to know in the second quadrant, sine is also positive, and this would be considered the reference arc or angle. Subtract this from 180 degrees, and that's the possibility for the second angle, which is 154.6. Now, here's what's going to happen. You check, you see A is 40 degrees. When B is 25.4 degrees, the sum is less than 180. This works out, you can continue. Look at this one. If we add these two numbers, we get larger than 180. So this is not acceptable. We have to find this. And if this number added to this angle is less than 180, then we have two cases. That's all you have to do. You don't have to memorize anything else. You calculate both of them. This works. This doesn't, because the sum of these two, let me just write it. I want to make sure everybody understands this. So let's write out 40 plus 154.6 larger than 180, and that's why it can't be done. Ignore it. We have only one triangle where A is 40 and B. The reason we put B1 because we have to do that, we have to check it out. B is 25.4. So what is C? Add these two, subtract it from 180. That means subtract 65.4 from it, you get 114.6 degrees. So we have all the angles and we have two sides. The missing side is the lowercase c. So you can use this with these two. Why these two? You can use it otherwise too, because this is given. didn't make any mistakes. It was given. Maybe in the process we make a mistake. That's why you rather use the given. So sine of 40 over 3 is sine of c, which is 114.6, over lowercase c, which is missing. So this is 114.6. This is 114.6. And we're going to use this one. Cross product means the c is 3 times sine of 114.6 divided by sine of 40. So cross product will result in this. Using a calculator, you come up with the answer 4.24, and you can put all of the information on this triangle. So you have the missing angles and the missing side. So the triangle is solved. SSA gave us only one answer, a unique answer in this case. Capital A is 35 degrees, lowercase a and b are given, and we want to solve this triangle. Well, without even having the triangle, even without drawing it, we can use this. Obviously, this part is given sine A meaning sine 35 over lowercase a meaning 6 is, we are going to use this. This is lowercase b, so sine B, which is missing, over lowercase b, which is 8. So we're going to use that because everything is known except capital B. Everything is known except capital B. So obviously, 6 times sine B is 8 times sine 35. So sine B is 8 times sine 35 divided by 6. Again, by now, we can handle this. And using a calculator, we'll resolve this. We have to use a calculator at this point. Gives us 0.7648. All right. If sine is given and we are looking for b, we have to use the inverse function. So what is the sine inverse of 0.7648? And in this case, you want to use many decimals. It gives you 49.9 degrees, and we're going to call it again b sub 1. Why are we calling it b sub 1? Again, sine is positive in the first quadrant as well as the second quadrant. Therefore, we can call this a reference arc subtracted from 180 to get to the second angle. And that's what we are going to do. Now, obviously, this works out because these two are less than 180. What about these two? What is the sum of these two? 165.1 degrees. Is that less than 180? Yes, that works as well. And that tells us we have two triangles. So we got to work this out. We got to work this out to finish and find both of them. So we have capital A, lowercase a, we have capital lowercase b, capital B, two of them. Now we're going to find lowercase c and capital KC. Now, the very first thing, capital C is very easy. We have two angles. add them up, subtract it from 180. So we have this 35 degrees here. We have this 8 here. We have this 6 and 6 here. As far as the name, this is capital C. This is lowercase b. This is lowercase a. This is b also. This is b. This is lowercase a. This is lowercase a. You don't have to worry about that. You don't even have to draw it. But understand that this creates two triangles that the angle B, okay, in this case and in that case, they are going to add up accordingly. In any event, so the next one is to add these two and subtract it from 180. So we have 84.9 degrees subtracted from 180, giving us 95.1 degrees. And now we can use the sine law. Sine of 35 over 6. We already have it. Now instead of sine B, we're going to say sine C, which means sine of 95.1 degrees for this triangle, over lowercase c, or lowercase c sub 1. This is lowercase c sub 1. Cross product will do the job. Six times sine 95.1 is c sub 1 times sine of 35. So c sub 1 is 6 times sine 95.1 divided by sine of 35. And that ends up being, using a calculator, 10.41. So this is lowercase c, okay? It may look like uppercase, but it's lowercase c, 10.42. For the second triangle, we're going to do the same thing, which means we're going to add these two, giving us 165.1 and subtract it from 180. So we're going to subtract this from 180, giving us 14.9 degrees. Again, we're going to use this one, sine 35 over 6. Sine 14.9 over c sub 2. Again, this is lowercase c sub 2. Cross product. C sub 2 becomes the product of these two divided by this one. And using a calculator with a couple of decimals, you're going to use a calculator on that. Gives us 2.69. So everything is done. To give you an idea, this was 35 degrees. This angle is 130.1 degrees. 14.9. This one is 95.1. 49.9. And this is C sub 2. And this is C sub 1. This is the large one. So again, this is one of them. Just in case, this is one of them. and the large one. Maybe I draw it here, it's easier to see. And this large one. Okay. So we have two of them. And as you can see, they both have the same h. The same h applies for both of them. Here's the next one. A is a 2, lowercase c is 1, capital C, the angle is 50 degrees. And we want to solve this one. Again, we have a SSA. By the way, quickly, this had two answers, okay? The case, that's why it's an ambiguous case, two answers. Now, in this case, let's go again with the sine law. Sine A over A is a sine C over C, because we got everything here, right? Except sine A, because capital A is missing, everything else is here. So plug in everything and find capital A. Plug in everything, which means lowercase a is 2, capital C is 50 degrees, lowercase c is 1, and we want to find sine A. Sine A is the product of these two, 2 times sine 50 and divided by 1. So simply 2 sine 50. And when we use a calculator, we get to 1.53. And we don't have any triangle like that. Why is that? Because sine is larger than 1. And it can't happen. Therefore, there is no answer. So this is how it's going to look like. The concept is simple. The larger the angle, and I'm going to write this, the larger the angle, the larger the opposite side must be. The opposite side must be larger. If you have a larger angle, the opposite side must be larger. For example, when you have a right triangle, the largest side is opposite the 90-degree angle, which is called the hypotenuse. In this case, it's not working because A equals 2 has to be opposite of an angle which is larger, and it doesn't work. Could somebody read this question, please? Class, could somebody read this, please? We have a few application problems. I'm going to ask you to read. I appreciate that. Could somebody read this for us, please?
A surveyor takes, oh, sorry, did you want to read?
Go ahead, Jamie. Go ahead,
Okay.
Jamie.
A surveyor takes two sightings of the peak of a mountain at a distance 900 meters apart on a direct line to the mountain. The observation are at angles of elevation of 47 degrees and 35 degrees, respectively. If the transit is 2 meters high, what is the height of the mountain?
Perfect. So let's look at this setting. It makes it easier to look at it here. We have a 35-degree angle, and none of them may be to scale. We have a 47-degree angle. This distance is 900 meters, and the transit is 2 meters. We want the height. Therefore, the height is b plus 2. So all we have to do, find b. We want to find B and add 2. So to find B, since we have this 35 degrees and we know sine is the opposite over the hypotenuse, we need to find C. So first and foremost, in this triangle, we're going to find this C. And how do we find that? This is 47 degrees. And these two, they give us a straight angle of 180 degrees. So C and 47 is 180. Therefore, C becomes 133 degrees. Now, if C is 130 degrees, maybe I want to erase this stuff. If this is 130 degrees and this is 35 degrees in this triangle, we can find A. So we are looking at this one. Capital A is 180 minus C and minus 35. And we know C is 133 degrees. So they add up to 168 degrees. Subtracted from 180, we get 12 degrees. So low uppercase A, in this case, this angle, this one is 12 degrees. Now we are going to use the sine law. Why did we need that? Because the opposite side is given. I hope you see in this triangle, the opposite side is 900. So sine of 12 degrees over 900 is sine of 130 degrees over lowercase c, and that's what we are looking for. So lowercase c is the product of these two, 900 sine 133, divided by sine of 12. Plug in. That's the answer. Now in this triangle, as I was mentioning, sine of 35 is b over c, where c we found it to be this number. So b is the product of these two numbers, which means 3165.86 times sine of 35 degrees. Using a calculator, we have 1815.86 meters. Plug it in here. In other words, add 2. And by the way, this is a rough estimate. If you change this to 1816, it's okay. It depends how they want you to do that. Probably they go with the nearest whole number, but either way is fine. So it's about 1816 plus 2, which is 1818. And as always, you must use the units. Could somebody read this, please?
Coast Guard Station Zulu is located 120 miles due west of Station X-Ray. A ship at sea sends an SOS save our ship call that is received by each station. The call to station Zulu indicates that the location of the ship is 40 degrees east of north, bearing north 40 east. The call to X-ray indicates that the ship is 30 degrees west of north, bearing north 30 degrees west. How far is each station from the ship? If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long would it take to reach the ship?
Excellent. Well, here's the setup. Everybody can see the setup here. And so first and foremost, if this is 50 and this is 60, we can find the value for C, which means 50 plus 60 subtracted from 180. All right, so we found this angle, C is 70 degrees. So we have this side, so we're going to use that. We're going to say sine of 50 over A, sine of 60 over B, and sine of C over 120. Of course, C is given, so let's write all of them. Sine of 50 over A, sine of 50 over A, sine of 60 over B, and sine of C. C, we found it to be 70 over 120. And that's the key. We have this one. So for X-ray, here's the X-ray. We want the distance A. So how far is each station from the ship? We want A. So we are going to use this one, everybody. So when you cross product these two, 120 times sine 50, and you divide it by sine 70, that's A. Using a calculator, you end up with 97.82 miles. In the case of a Zulu, we want to find B. This cross product, 120 times sine 60 divided by sine 70, using a calculator will result is in 110.59 miles. If a helicopter is going to use the nearest station, since this is the smaller number, this is the one that they're going to use. And T is D over R. In this case, the distance is A because it's the smaller of the two. 97.82 divided by R, the rate or the speed, which is 200 miles per hour. Using a calculator, we end up with 0.42 hours. And if you multiply this by 60, gives you about 29 minutes. Again, I want to make sure everybody understands how we arrive at it. This one, if you multiply it by 60, it gives you the number of minutes. All right, we have a couple more questions. Could somebody read this, please?
The highest bridge in the world is the bridge over Royal Gorge in the Arkansas River in Colorado. Sightings to the same point at water level directly under the bridge are taken from each side of the 880-foot long bridge as indicated in the figure. How high, H, is the bridge?
Perfect. First, to make sure we understand what's going on, let's look at the drawing a little bit more with details. First of all, this distance, we're going to call it X. So this is what we have. This distance, we're going to call it H. So this is our X, okay? Now, we are looking for H. And I hope you realize one easy way to find H is to use this angle and this one, sine of this angle. This is a 90-degree angle. Sine of 69.2 is H over X. So if I have X, I can come up with H. So we are looking for X. So how do we find X? And that's the idea. So we have 69.2 degrees here. We have 65.5 degrees here. We're going to add them up and subtract it from 180 to get to C. So we find C. Now that we have a C, we can use the sine law in order to find X. So sine of, and this is oppositely 65 point. So sine of 65 point over X is sine of this angle, 45.3 over 880, because we have this number. And X is the product of these two divided by this one. So 880 sine of 65.5 over sine of 45.3, and that's X or AC, X or AC. Using a calculator gives us this number. So all we have to do, put it in here. We do that. And H would be the product of this one and this number. So 1,126.57 times sine of 69.2, which requires using a calculator, gives us the height of 1,053.15 feet. So we got what we were looking for. We are going to look at the last question. Could somebody read this, please?
The navigator of a ship at sea spots two lighthouses that she knows to be 3 miles apart along a straight seashore. She determines that the angles formed between two line-of-sight observations of the lighthouses and the line from the ship directly to shore are 15 degrees and 35 degrees. How far is the ship from lighthouse P?
Excellent. So to make some sense out of this, let's do the drawing here. So this is 15, this is 35, this is 3 miles. Let's find all the angles. Well, bear in mind this is 90 degrees. If this is 15, this 2 must add up to 90 degrees. This 2 must add up to 90 degrees. So this will be 90 minus 35. Let me write it here. This will be 90 minus 35 degrees. This will be 90 minus 15 degrees. So this becomes 55 degrees. This becomes 75 degrees. And or this angle is 15 plus 35 or 50 degrees. This angle is 50 degrees. So we got that. Now, we want to find how far the ship is from lighthouse P. So we are looking for PR. That's the idea. So sine, and we have this side. So sine of 50, sine of R, sine of 50 over 3 is sine of 55 over the missing PR. So sine of 50 over 3. Now cross product, 3 times sine 55 divided by sine 50 is PR. Using a calculator will give us 3.21 miles. We're going to use the same thing, sine 50 over 3, but this time sine of 75 over QR, because that's what we want for the second part. And therefore QR is 3 times sine 75 divided by sine 50. And using a calculator would result in 3.78 miles. How far is the ship from the shore? We want this distance, which is the H, if you will. There are many different ways of handling it. One of them would be sine of 90 over 3.21. Remember, this one is 3.21 maybe. This is 3.2. This side is 3.2. And this side is 3.78. So in this top triangle, this one, sine of 90, this is 90 degrees, opposite this side, sine of 90, opposite PR, which is 3.21, equals sine of 75, opposite the H we are using, we are looking for. So again, maybe I draw this. So I'm looking at this one. This is H. So H is 3.21 times sine of 75 divided by sine 90, which we know it to be 1, by the way. Sine 90 is 1, and the answer is 3.1 miles.